Okay, see Lindelof videos. I want to take double angle formulas for trigonometric functions and verify some IDs. So hopefully you have your trig identities memorized, or at least on flashcards, so you can go back and use these. So I'm going to assume some stuff. So here we go. First thing I'm going to do is you see that we have this sine theta plus cosine theta quantity squared is said equal to 1 plus sine squared theta. So we're supposed to move the left-hand side around to prove that it's equal to the right-hand side. We're not going to move both around. So first thing I'm going to do is do some algebra here. And the algebra I'm going to do here is FOIL, right, because we have this squared here. So when I square this thing out, that gives me sine theta plus cosine theta times sine theta, theta plus, I'm not going to be able to fit it, cosine theta. Damn if I didn't. Cosine theta. When I do all this stuff, right, when I do all my FOIL, I'm going to get sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. Holy crap. So all of this in white is this piece up here in yellow. So it's this piece right here, right? I expanded that out. Then I'm going to just leave my right-hand side alone, and that's how you're supposed to do it. You're supposed to just move one side, right? So here we go. Now I'm going to use a trig identity that I know, and I happen to know that this piece right here, 2 sine theta cosine theta, is equal to sine squared theta. So I'm going to use this double angle thing right here, and then I'm going to put all the other crap back that I had, right? Cosine squared theta, bring down, I'm going to bring down this sine squared theta, right? Plus, and then set it equal to this junk on the other side. Again, I'm just going to keep bringing that down, right? So far, so good. So that's how I'm going to do this. Now, every time we're doing this crap, we're just looking for trig identities that we can use. So if we look at this piece right here, well, sine squared theta plus cosine squared theta is equal to 1. That's a Pythagorean identity. So I'm going to take my sine squared theta. This plus sign is this one, right? And then we know that sine squared theta plus cosine squared theta is 1, so I'm going to use that as my replacement value here. It's equal to 1 plus sine squared theta. And if you see, I mean, you can turn this around if you want, sine squared theta. And if your professor asks you what your proof is here, this is proof through the reflexive property, right? That it says the same thing on both sides. So that's my proof of that. I'm going to do another one. I think that I'm going to stop here, and then on the next video I'm going to go ahead and do 2 of them because I don't want to go through too much time. If you go to see the second video, would you please consider having your textbook open or your flashcards or however you're doing it so you have your basic trig identities with you. It will really help. Hey, thanks for watching. If you have any questions or comments, please let me know.